Assalamualaikum warahmatullahi wabarakatuh. My name is Syafierul Akiemie from Group 3. I will introduce you about this slide. Is for the subject BBO 21403 heat trimmer and machine component. So my name is Syafierul Akiemie again, and I will continue my slide. So I hope you enjoy my slide, our group presentation. Thank you. So for this topic, our group picking a topic about analysis of the upshot of heat treatment on physical and mechanical behavior of aluminum hybrid composite. So for the introduction for this topic, the need of material with high property and reduced weight has become increasingly popular in recent time. Aluminium also meet the requirement for a variant of application in aircraft and also automobile components. Aluminium is considered to be the most commonly used material because of its cost and superior properties. Number 2, heat treatment is kind of process of heating and cooling the material for achieve custom property by changing a crystal structure. The selected of the correct heat treatment circle including process parameter and a controlling factor in the adaptation of many heat treatment circle such as aging, quenching, tempering and so on available for the same. So therefore many research have undertaken variant heat treatment cycle for composite and feature improvement analysis. So giving a advanced material such as aluminum 06061 are using in aeronautical application. The scope of this article is to analyze the result of process and heat treatment parameter on the same behavior. For this paper focus mainly of the development of aluminum based mix with a steering assist casting technical in which aluminum and graphite are reinforced in 6061 aluminum. Metrics are the analysis of the process constraint result and sample characteristic. Next slide is experiment. Aluminum 6061 is used as a base alloy with aluminum 203 and graphite are used as fillers. Hybrid element were reduced and produced the developed sample using mixed material. So aluminum 061 was restored to be molten stage by heating a sample at 750 to 860 Celsius through a heating element in the enrichment. The micro was also preheat at about 450 Celsius and out into a melting matrix and combine use a mechanical stirrer. Then the mixture was deflated into a preformed graphite flakes and flared to freeze. Finally, the sample was separated for experiment evolution. So the next slide, as we can see, table 1 parameter selection. Parameter is level 1 reinforce 5, steering time 5, steering speed RPM 500. For level 2 will increase by reinforcement 12, steering time per minute 10 and steering speed RPM increase 750. For the table 2, this experiment, we have experiment number, reinforcement, steering time by minute, and also steering speed for RPM. So as we can see, this experiment is following by the flow. So number 1 is input factor, number 2 is steering casting, and go to the heat treatment, and lastly output response have separate by 2. So number 1 is comparison, number 2 is analysis and optimization. So as we can see, the figure 3 comparison of hardness pre and post heat treatment. We can see the graph starting by preheat treatment, goes to annealing, and goes to normalizing is increased. But after that, when the quenching and the tempering, the graph start decrease. So we will look forward for this experiment. For the result and discussion, microstructure studies in figure 2, we can see the picture of A is preheat treatment and picture of the B is post heat treatment. The morphology of the consolidated sample is determined use FESUM, wherein the morphology and dispersion of the fillers in the aluminum metal are observed. In figure 2, A and B display the morphology of the sample pre and post heat treatment. We can see the diagram of the picture is before and after heating. After the completion of the heat treatment cycle, because of the development of grain border indicate in blue coloring. So we can see such concern in vital of the upshore in the strength of specimens. So finally, in microstructure is also detected in the micrograph on comparison between pre and post heat treatment of the specimens was lead to cool and room temperature. The properties were measured, analyzed, and compare pre and post heat treatment.
Okay, I will continue this slide. Result and discussion. Hardness. The hardness is determined and compared by taking the mean of 3 readings as relevant in table 3, as the functionality of the composite is mainly governed by hardness. The hardness value are found to surge post heat treatment. The rise in the hardness value may be owed to the homogeneous dispersal, the load-bearing ability of fillers, refinement of crystal structure after heat treatment, and development of intermetallic combination. The maximum hardness improvement is obsessed in the annealing and normalizing of 38.2 HRB, which may be owed to the cooling rate and its corresponding grain refinement. In quenching and tempering also, an increase in hardness is observed, which may be credited to the same cause. So, heat treating of composite is considered to be very valuable to the enchantment in hardness as revealed in Fig 3. As you can see, as the table 3 hardness, there has 4 numbers of experiment and Rockwell hardness value HRB before heat treatment, after heat treatment annealing, normalizing, quenching, and tempering. So for number 1, for HRB is 40.53. After heat treatment handling is 47.4, normalizing 45.1, quenching 45.4, and tempering 45. Number 2, 40.5. After heat treatment handling is 45.8, normalizing is 48.2, quenching is 47.65, and tempering is 47.35. Number 3 is 41.56. After heat treatment is 48.2, normalizing 46.8, quenching 47.05, and tempering is 46.6. And number 4 lastly is 39.5. After heat treatment it becomes 47.1, normalizing it becomes 45.1, quenching 46.8, and tempering is 47.2. This is figure 4, variation of hardness, pre-heat treatment for B, handling for C, normalizing, D, quenching, and for E is tempering. So as you can see at the table, the steering rate and duration are observed to be the major governing constraint beforehand and subsequently after heat treatment for hardness value. Pre and post heat treatment, the hardness value is found to surge with a surge in filler content as the load behavior volume is improved while the filler content is increased in figure 4 from fig 4, whereas the hardness is found to upsurge with a heave in the mixing period, which may be credited to the even distribution of the filler, which may in turn induce more grain refinement. Similarly, for the same above said reason, the hardness is again observed to elevate with elevation in steering rate. Density. The density is also determined to compare by taking the mean of 3 readings as revealed in table 4, as the density of the samples governs the porosity in the specimen, which in turn influence the mechanical characteristic. The density values are found to surge post-heat treatment as similar to hardness, which may be owed to reduction in porosity of the specimen. Similar to hardness, the porosity of the composite got reduced owing to the refinement of crystal and grain structure after treatment. The maximum density of 3.884 is found in quenched samples, which is due to rapid cooling in quenching. Comparatively, a significant improvement is also found in tempered and annulled samples than normalizing samples due to the degree of refinement of grains. So, heat treating of composite is considered to be very valuable, and the enchantment is density as revealed in figment 5. After heat treatment, refinement of grain structure in the principal cause for the reason for the increase in density of the composite. From table 4, it is clear that a 6 to 22% increment in density is observed post-treatment. The main effect variation of density values pre and post-treatment are revealed in figment 6. The filler content is detected to be the key governing constraint beforehand and subsequently after heat treatment for hardness values. The density value is found to surge with an elevation in reinforcement content the most of the course of the study, as the filler content reduce the porosity, which in turn affect the density, whereas the steering rate and duration do not do not depict a standard variation cornering output properties. In the case of normalizing and quenching, the density is found evaluate with a surge in duration and to the contrary in annealing and tempering. Stirring speed despite only proportional variation in the majority of the case due to the homogeneous blending, where the tribology characteristics of the specimens are also determined and compared by measuring the frictional coefficient (COF) and mass loss as revealed in Table 5, as the wear test is one of the characteristic tests for the application of samples. The COF and mass loss are found to decline post-heat treatment as the hardness and density of the specimen are improved by refinement of gain structure as depicted in Fig 7. The minimum COF of 0.334 is observed in annual samples, and similarly, a decrease in COF is also observed in other heat treatment cycles. Otherwise, the decrement in mass loss during the wear treat is also observed in heat treatment samples. Again, like COF, a minimum mass loss of 0.0015 gram is observed in analyzed samples, so it is better evidence that wear characteristics have gained an improvement in COF and mass loss after heat treatment of the specimen as revealed in Figment 8. As you can see for the table 5, we have the experiment number, coefficient of friction before heat treatment, after heat treatment annealing, normalizing, quenching, tempering. Mass loss before heat treatment, after heat treatment annealing, normalizing, quenching and tempering. For number 1 is 0.349, 0.339, 0.348, 0.346, 0.338. And for mass loss before heat treatment is 0.0021, after heat treatment is 0.0015, normalizing is 0.0018, quenching 0.002 and tempering is 0.0021. Number 2, before heat treatment is 0.352, after heat treatment for analyzing, normalizing and quenching and tempering is 0.345, 0.347, 0.346 and 0.385. Mass loss before heat treatment and after heat treatment for annealing, normalizing, quenching and tempering is 0.0025, 0.018, 0.022, 0.019, 0.019. Number 3 is 0.384, 0.34, 0.355, 0.32 and 0.376. For mass loss before heat treatment is 0.21, 0.0016, 0.0019, 0.0019 and for tempering is 0.002. And last but not least, before heat treatment is 0.404, after heat treatment for annealing is 0.344, for normalizing is 0.352, for quenching is 0.349, for tempering is 0.376. For mass loss before heat treatment is 0.0023, after heat treatment for annealing is 0.018, normalizing is 0.0018, for quenching is 0.0018 and for tempering is 0.0021. For Figment 8, after heat treatment, refinement of grain structure is the principal cause for the reason for the improvement of wear behavior of the composite. From table 5, it is clear that a 3 to 5% decrement in COF and mass loss is observed post-treatment. The main effect variation of COF and mass loss values pre and post-treatment are revealed in figment 9 and figment 10. Thank you.
We will continue this slide, result and discussion. Figure 10, variation and mass loss pre-head treatment, annealing and normalizing. This filter content is detected to be major covering constraint beforehand and sequential after heat treatment or C or F value. From figure 9, it is ostensible that the COF is found to evaluate with this gas is disperses content which meant by this word to grow and intermediate handstand. Likewise, the COF is found to drop the gas in citrine during duration which can be on to an instance blend of mixture. The same trait as filler content is followed the citrate rate in this case of COF from figure 10. It's noticeable that weight loss is noticed to decline gush with dispenses amount which may be on to development of metallic handstand depicted in figure 11. Likewise, the weight loss is faces to gas with evaluation in string interval and rate which may be on to instance blend of mixture. Taguchi analysis optimization. Taguchi analysis is employed to determine the optimal condition is which is better output responses considering processing constraint. This same is determined using SN graph, which is aid to predict the condition to which improve the characteristic can be obtained. The condition is with maximum SN value obtain the aspect to predict the improved characteristic. The SN graph is hardness density, consequence of features, and mass loss revealed in figure 12, 13, 14, and 15 respectively. The criteria for optimization are selected according the output characteristic of study, and confirmation tests for the same are conducted to confirm analysis with those results are revealed in table 6. Figure 12 as an graph of hardness pre-treatment, normalizing, quenching, and tempering. This is figure 13 as an graph of density, preheat treatment, annealing, normalizing, quenching, and tempering. This is figure 13. Figure 14 is SN graph of consequence of fractures. A. Heat treatment. B. Annealing. C. Normalizing. D. Quenching and tempering. Same with figure 5. SN graph of mass loss. A. Heat treatment. B. Annealing. C. Normalizing. D. Quenching and E. Tempering. Table 6 is show about confirmatory test. First, output response, hardness. Preheat treatment, annealing, normalizing, quenching, and tempering. The predict optimal condition, responsive. For heat treatment, 5. Annealing, 12. Normalizing, 5. Quenching, 12. And tempering, 12. Strict time for heat treatment 5, annealing 5, Annulate 5, normalizer 10, quenching 10, temperate 10. For stripping speed, RPM, heat treatment 715, heat annulate 500, and normalizing 750. Same with quenching, tempering. For predict output response value, 40.5225 for heat treatment, annulate 47.125 for normalized, for 46.7.25 for quenched, 46.5375. Okay. And experimental output responsive value for heat treatment 40.432, for annulate 46.182, for normalized 47.18, for quenching for 47.13, for temperate 47.35. This is show system with density, coefficient of friction, and mass loss. As you can see for this slide in table 6. In conclusion, the aluminum hybrid composite is produced by employing the steel casting technique in profilating aluminum as a base if alumina in graphite as reinforcement and subjected to heat treatment process like annealing, normalizing, quenching, and tempering. The sample is tested for their mechanical and physical behavior beforehand and afterward heat treatment. The hardness is specimen increased by 15 to 17% after treatment due the respine to gain structure. The density value is found the severe post-heat treatment are similar to hardness, which may be owed to reduction and porosity of specimen. During the wear test, the filler contained the detected to be measure of covering constantly beforehand and self-conscious after heat treatment COF value and waste loss noted to decline the dispersion amount with might be on the growth to intermediate formation. Behavior and effect of constraint will analyze to normalizing using Taiguchi analysis value. Also predict to confirmation based on SN graph different using analysis. That's all from group us. Thank you.